if all the angles, if corresponding angles are congruent. Now remember, when we did parallel lines in a transversal, the corresponding angles were the angles that matched up, right? Same angle in the same position. So these corresponding angles are the angles that match between the two polygons, okay? So all of the angles have to be congruent. The corresponding angles have to be congruent, and the corresponding sides have to be proportional. They're not congruent, because if the corresponding sides were congruent and the angles are congruent, it would be the exact same figure, right? They would be the exact same size. And those would be congruent polygons. Okay? These aren't congruent polygons, they're similar, which means one's just, it's all the same angle, so that means it's in the same shape. One's just bigger or smaller. It's just expanded or shrunk, all right? And so corresponding angles are congruent, corresponding sides are proportional. And because the corresponding sides are proportional, that means that the perimeters are also proportional. So if all the sides are proportional, then the perimeter logically has to be proportional also. And what I mean by when I say proportional, remember I said one figure is just expanded or shrunk. So if this figure right here is twice the size of this figure, then the perimeter is also going to be twice the perimeter of that figure. Does that make sense? Okay, so if we're looking at corresponding sides, FG corresponds with BC. It's the side that matches that one. Now, all of these figures, they don't always put the figure shaped exactly the same as the others. One of them might be turned. Okay, so they're not always nice and neat, beautiful right next to each other. They might take two figures that are similar and then turn one of them. And you have to be able to figure out what side matches to what side. Okay? And when we try to figure out which side matches to what side, you can use the angles to figure those out. Because if the angles are congruent, you look at, for example, these angle markings, we know that this angle C only has one congruency marking, and angle G has one congruency marking, right? So that means these C and G are congruent. Likewise, B and F, B has 4 congruency markings, and F has 4 congruency markings. So those two angles are congruent. So you have to use those markings to figure that out. Now, let's look at their sides, okay? FG is between angle, I'm just going to call them angle 1 and angle 4, okay, because I'm looking at the number of markings. So FG is that side that's angle 1 and angle 4. Well, angle 1 and angle 4 is CB, so you can look at that, okay? And sometimes it's kind of like a scavenger hunt to figure out which side corresponds with what side. This one's easy to see. So it's not that difficult. You can tell what's the top, what's the bottom, what's the left, and what's the right. They're not always that easy to see, take my word for it. And so, because we can look at this and we know that all the angles are congruent and all the sides are proportional, we say that this figure, ABCD, is similar. This is the marking for similar. Okay, it's like a congruency symbol without the equal sign. That means it's similar to figure EFGH. Now, that similarity statement tells us everything we need to know as if we didn't have the picture. Okay? If we didn't have the picture, we could look at this similarity statement and you can match up corresponding pieces based on this statement right here. This is angle A. It corresponds with angle E. You look at the order those letters are written in. So, angle B corresponds with angle F. Angle C corresponds with G. D corresponds with H. So we could look at all of the angles and know which ones are congruent just based on this similarity statement. We can also figure out which sides are corresponding sides. For example, AB corresponds with EF. BC corresponds with FG. Do you see that? We're looking at the order that these are written in, and that tells you which sides correspond with what. CD corresponds with GH. That's the last 2 letters correspond to the last 2 letters. And then the last one, AD corresponds with EH. Okay? So we could, like I said, we could look at the similarity similarity statement, and if they give you that, then you don't have to try to visualize, if I turn this and flip it, what matches what. Use the similarity statement to get what you need. All right? What right here is called a statement of proportionality. Okay, that's just telling us what corresponds with what. Each side that corresponds with another side of the other figure forms a ratio. Okay, and so AB corresponds with EF. So that means AB, which is this side, if I divide that by its corresponding measure, that gives us a ratio. And that tells us what's called the scale factor. Okay? Now, AB divided by EF, if it's proportional, these are proportional, they're similar figures, that ratio is going to be equal to BC over FG, so this over this. And that's going to be equal to CD over GH, so that's going to equal this divided by this. And then lastly, that's going to equal DA over EH. Okay. So in order for it to be similar, in the first set of problems, it'll ask you, are they similar? You have to check all those ratios and make sure they're all equal. Okay. Let's look at this first example. So this says decide whether they're similar. First thing you want to check is you want to make sure that all of the corresponding angles are congruent. And so angle X is congruent to angle Q. Y is congruent to R, W is congruent to P, and Z is congruent to S. So it looks like all four of my angles are congruent. All four angles in one figure is congruent to all four angles in the other. Okay? And then we check our corresponding sides. Okay? We check their ratios. We check to make sure that they are proportional. And so you have to check all four ratios and make sure that they're all equal. And so I'll start at the top. So 6 over 4 has to equal 9 over what? 9 over 6. And that has to equal 15 over what? 10. And that has to equal 12 over 8. Okay? If they're similar, then all four of those proportions, all four of those ratios, they'll all be equal to each other. And so when I take my calculator and I do 6 divided by 4, what do you get? 3 over 2, which is 1.5, right? And then do 9 divided by 6, and you get 1.5. 15 divided by 10, you get 1.5. 12 divided by 8, you get 1.5. Now, you said 3 over 2. That's correct. If I take each one of those fractions and reduce it, they're all equal to 3 over 2, correct? So all of my sides are proportional. You can't just have two sides proportional to the other sides. They all four, the ratios have to be the same. That scale factor that I was talking about, that is, for example, if you had one that was twice as big as the other one, the scale factor would be 2 to 1. Okay? If it was 3 times as big as the other one, it'd be 3 to 1. Well, this one, the scale factor of WXYZ to PQRS is 3 to 2. If I took any one of those fractions and reduced them, I'd get 3 over 2, right? Okay, what's another way to write 3 over 2? Well, 6 over 4, yeah, but if I don't want to write it as a fraction, 1.5 is a decimal, but there's another way. There's another way that you can note 3 over 2. Another marking that you could use that shows a ratio. 3.2. Y'all remember that? That is the same thing as 3 to 2. When they ask you the scale factor, it'll be written like that, 3 to 2. That's the same thing as 3 over 2. That's just another way to write a ratio. Okay? And so, what that means is, we know 3 divided by 2 is 1.5, right? That means that this bigger figure is 1.5 times the smaller figure. So if I took 4 and multiplied it times 1.5, it would equal 6. It's 1.5 times bigger than the smaller figure. It's the scale of one figure to the other. Does that make sense? Okay, so if I knew the scale factor, if they told me the scale factor of these two figures was 3 to 2, and then they told me all the measurements of this one, I could find all the measurements of this one, because I could take this and multiply it times 1.5, and it would give me the bigger figure. And vice versa. If I knew the scale factor was 3 to 2, and they gave me all the bigger figures, how would we find out the small one? Divide it by 1.5. You take 6 divided by 1.5, it'll give you 4. Okay? So the scale factor is how many times did it increase or decrease? Okay? Any questions? Yes. The scale factor of 2 to 3 is the scale factor of the smaller one to the bigger one. And that is a very good point, because on your worksheet it'll say, find the scale factor of the smaller figure to the larger figure. And so that means the number that goes on top has to be the corresponding piece of the smaller piece, the smaller figure first. Okay? So the scale factor of WXYZ to PQRS is 3 to 2. But the scale factor of PQRS to WXYZ is 2 to 3. Okay? So you have to read those directions carefully to make sure that you're answering the question that they asked. Okay? That was a good question. Any other questions? Okay. Is anyone not finished copying? Okay. So this first problem, it tells you, it just says number 1, but there's nothing to answer for number 1. Number 1 is just a piece of information. It says quadrilateral JKLM is similar to quadrilateral PQRS. And then we have to find the value of Z. So I'm going to let you get this copy down, and then we'll talk about it. Okay, so it tells us what's similar to what. Now, these figures are not drawn perfectly next to each other, right? They're not. And so I know from the similarity statement that JKLM is similar to PQRS. So that means angle J has to be congruent to what? J and P, right? K and Q. So K is congruent to Q. L and R. L and R. And then M and S. Right? That's going to help us, that's kind of a roadmap to help us figure out which sides are corresponding, because we have to set up a proportion. For every one of these, you're going to be setting up a proportion, cross multiply, and solve. Okay? And so, when I look at 15 KL, that's between 2 and 3, right? So QR is the corresponding side that matches this. Okay? And like I said, you think, well, duh, I could look at the picture and figure that out. Sometimes you can. Trust me. Okay? So get used to looking at it like this. And so I know that 15 corresponds with 6. So that's 15 over 6 has to equal, and then JK is between 1 and 2. So QP is also 1 and 2. So that's 10 over Z. So then we cross multiply. So 15Z equals 60, right? And so divide by 15. So Z equals what? 4. Okay? Any questions? Now, for this example, they told us they were similar. For the next one, they're asking us, are they similar? Based on the information they give us, are they similar figures? Okay, are they similar? Yes, they are. Okay, so we see that 89 is congruent to 89, 82 congruent to 82, but we need to know the rest. First of all angles in a quadrilateral add up to equal 360. So the missing angle in the smaller one, if I add these up and subtract from 360, I get 102. So that tells me that this one is congruent to that one. And here, if I add them up and subtract from 360, I see that that's 87. So that means this one is congruent to that one. So all of my angles are congruent. And then I have to check to make sure that all of the sides are proportional. Okay? So 6 over 12 has to equal 4 over 8. That has to equal 5 over 10. And that has to equal 7 over 14. And they all do. That's 0.5. That's all 1/2, right? So all of these are proportional. What's my scale factor of the smaller one to the bigger one? What's the scale factor of the bigger one to the smaller one? 2 to 1. Okay? Very good. They didn't ask for that, but you have to know how to find it. So 1 to 2 or 2 to 1, depending on which one they ask you first. Okay? Any questions? So all you do is you take that ratio and reduce it. Okay, let's look at this example here. It says in the diagram, and then it gives you the similarity statement. It tells you what is similar to what. So then you know what angles are congruent. You know which sides correspond with which sides based on that similarity statement. It says list all pairs of congruent angles and write the statement of proportionality for the polygon, which means write what sides correspond with what sides and write them as ratios. Like on the first page of your notes, it has the statement of proportionality. You need to write that out. Number 5, find the scale factor of. Pay attention, what to what. And then number 6, find the length of TW. And then number 7, find the measure of angle TUV. So y'all try to do that. There's some markings on these figures that we didn't see before. They show you what's congruent, but there's also something else. What's the added marking? Parallel, right? So if this is parallel to this, then that tells us something. Okay, number 4, list all pair of congruent angles. I don't even need to look at the figures. I can look right here and list them all. Okay, angle T is congruent to angle A. So, angle T congruent to angle A. Angle U is congruent to angle B. Angle V is congruent to angle what? C. And then last, angle W is congruent to what? Angle D. Everybody got that? Yeah? Any questions on that? Now, we have to write the statement of proportionality. Okay? So, again, I don't even need to look at the figures. I can look at my similarity statement and write that. Okay? So, this is you're writing what segments correspond with what segments, and you're writing that as a ratio. So, when I look at the first two, TU corresponds with AB. So, TU over AB has to equal, then I look at the second one, UV over BC. And that has to equal, what's the next set? Very good. VW over CD. And that has to equal, what's my last set? Very good. TW over AD. That's my statement of proportionality, showing me everything that's proportional. Now, Number 5 says find the scale factor of TUVW to ABCD. So you need to find two corresponding parts to compare. So TUVW, that's the bigger one. So when I look, I need to find two corresponding parts. Well, I see that this and that are corresponding parts, right? They're the only two sides that I know. I can't use 23 because I don't know what this corresponding part is. And so it's the bigger one to the smaller one. So it's 15 over 9. And then we just reduce that. If we divide them both by 3, we get 5 over 3, right? So we write that. That's not 3. So the scale factor is 5 to 3. Now, if it had asked us for ABCD first, then it would be 3 to 5. Okay? Next, it says find the length of TW. TW, that's this right here. So I'll call that X. And so we have to set up a proportion. Corresponding parts equals corresponding parts. Okay? And so now it doesn't matter which one you do first, as long as you keep that same pattern. Okay? So I'll do big one over small one equals big one over small one, just because the big one's on the left. No reason. Okay, so we know, if we know our scale factor, that's the first thing we can write. So 15, well, the scale factor is 5 to 3, right? So you could either put 15 over 9 equals, or you could put 5 thirds equals. So 5 over 3. Well, let me do this down here where I have more room. So number 6, 5 over 3 equals X over 6. Everyone see where I got that? Yeah? Okay. So now we just cross multiply and solve. So 3x equals 30. Divide both sides by 3, so x equals 10. So that means this is 10. TW is 10. Y'all be good on that one? Any questions? Okay, and then number 7, find the measure of angle TUV. Well, angle TUV is this right here. Okay? What angle does that correspond with? Angle B, right? This angle is congruent to that angle, okay? TUV, look up here. TUV corresponds with ABC, so that's angle B, right? So these two are the same. Remember, these parallel lines, that's saying this line is parallel to this line. That makes this a transversal. So these two angles are what? Supplementary, because they are consecutive interior angles. They're consecutive angles. So that means they're supplementary. So if this is 70, what's this? So this is 110, which makes this 110. So angle TUV equals 110 degrees. Okay? Any questions? No questions? Okay. So let's see if you can figure these out. So it says the polygons in each pair are similar. Find the missing side length. So it's two separate problems. In the first one, they don't draw them matching up directly equal to each other. So you got to figure out which sides match what sides. What corresponds with what. So that you can set up that proportion. The question mark is the side you're solving for. In the second one, you're still solving for where the side with the question mark, and all they tell you is the scale factor from A to B. So you have to set up that proportion correctly. Okay, y'all try that. Okay, so for the first one, you have to look and figure out what sides correspond with what sides. Okay? Well, it looks like they took the first figure and they flipped it upside down to get the second figure, right? And so we can see that this corresponds with this. But you need to recognize this is the long side of one of the bases, right? It corresponds with that. That's the long side of the other base, okay? And so when we write our proportion, we'll call this x. So x over 25, that equals 28 over 35. Okay? And so then we cross multiply, and we get 35x equals 25 times 28, 700. Divide both sides by 35, and you get x equals 20. Okay, so the question mark equals 20. All right? Any problems with that one? Is it okay? Good? Okay. Now, the second one, we need to figure out this. So we'll call that x. Okay? Well, we can see x corresponds with 30. Okay? We can see that. The figures are drawn the same next to each other. But your scale factor from A to B is 5 over 6. So from A to B is 5 over 6. So that's A over B, right? So when you set it equal to corresponding parts, it has to be a corresponding part of A over the corresponding part of B, because that's how you have this set up. And so it'll be 30 over X. Okay? Or if you did it the other way, if you did X over 30, that has to equal 6 over 5. Because it has to be A over B equals A over B. They have to match. That pattern has to be the same. If you put a piece of A over a piece of B, it has to be the same with ratio that you set it equal to. Okay? And so now that's 5x equals 180. Divide by 5, and x equals 36. So the question mark equals 36. Any questions? How's y'all doing that one? Y'all got that one right? You understand now? Okay. Does anybody have any questions? Okay, I have a couple more for y'all to try where you're solving for x. Okay? For your same thing, you're going to have to set up a proportion and you're going to solve for x. Is anyone not finished with this before I move it down? It says, solve for x. The polygons in each pair are similar. Okay, so let's see how we did. And so when we set up our proportion, okay, we know we have to solve for x. So it has to include this side corresponds with that side. So that has to include. And you have to look at any other two sides that you have all the information for. Any other two corresponding sides that you have all the information for. I can't use 30 because I don't know what this is. Okay? And so I can use that 30 and that 36. Okay? Because those are corresponding sides. And so we do 30 over 36 equals 7x minus 2 over 48. So now when you cross multiply, you need to make sure 7x minus 2 is all together. So you need to make sure that when you do that, you distribute that 36. And so we have 30 times 48 is 1440 equals 36 times 7x minus 2. So we distribute the 36, so 1440 equals 252 x minus 72, right? Sure. You didn't distribute the 36? Did you set it up 36 over 30 equals 48 over 7x minus 2? You might, that's fine. That's fine. As long as you'll still get the same thing. If these two are flipped, these two have to be flipped, then it's still equal. Okay? And so 1440, we add 72 to both sides, and you get 1512 equals 252x. Divide both sides by 252, and you get x equals 6. And that's all they wanted you to do was solve for x. Okay, so that's all you had to do was solve for x. But just like the last section of chapter that we did, you need to read those directions carefully. Because if it says solve for x, you're done. But if it says find side AB, then you may have to go back and plug x in. All right? And so for number 2, for the second one, we need to know what is congruent to what in order for us to figure out what the corresponding sides are. So I can see that this angle, they gave us that, is congruent to that angle. When I look at my other 2 angles, this is an acute angle, right? Just based on looks. And this is an obtuse angle based on looks. Well, this angle, this is the obtuse angle, has to be congruent to the obtuse angle in the other one. So M is my obtuse angle. So that means D is congruent to M. Okay? And likewise, this is my acute angle. It has to be congruent to the acute angle. Because if they're similar figures, all those angles are congruent. Okay? Now, like I said, don't try to base those corresponding sides on just how it looks. Because sometimes they can get tricky. Okay? So now that I know what angles are congruent to what angle, I can figure out my sides that are corresponding. So I see this 121 side CE is between angle, I call it angle 1 and angle 3, right? So between 1 and 3 on the second figure is in L, that's 55. So I know that this angle corresponds with that angle based on their placement. Do you see that? Okay? And then when I look at, I need to figure out what corresponds with 66. Well, that's between 1 and 2, correct? Between the 1 and 2 hash marks. So between the 1 and 2 hash marks is that. So this side, CD, corresponds with LM based on its placement. That segment is between those 2 angles. So it has to be the same segment between those 2 angles in the second figure. So now we can set up our proportion. 121 over 55 equals 66 over 4x minus 6. Okay? Now, if you have it reversed, if you have 55 over 121 equals 4x minus 6 over 66, that's fine. As long as they're both reversed, then it's still equal. Okay? And so now we cross multiply. So we have 121 times 4x minus 6. That's equal to 55 times 66, which is 3630. Now we distribute the 121, and we get 484x minus 726 equals 3630. We add 726 to both sides, so you get 484x equals 4356. Divide by 484. That was ugly. And you get x equals 9. How do we do? Good. Y'all set that up correctly? Good. Any questions? Nope, no questions? Okay, same thing. We're not learning a new concept, but this picture looks different. The triangle built inside of another triangle. Is anyone not finished with this before we move on? Oh, ignore that. Okay, Okay, so we have a triangle inside of another triangle. If you have a triangle built into another triangle, you can automatically assume that they are similar. Okay? They have to be. All of their angles will be the same because if you have a triangle inside of another triangle, this top triangle will be the same for both of them, right? I mean, the top angle will be the same for both of them. This line is going to be parallel to this line, okay? And because they're parallel, this angle will be congruent to this angle because this is considered a transversal, like TV will be considered a transversal. So this angle E will be congruent to angle B, okay? And likewise, this angle C will be congruent to W. So anytime you see that picture, which you will see it, it's like a triangle built into another triangle, you can assume that they're similar. Now, in order to set up the corresponding sides, it may not always be as easy to see what side corresponds with what side. And so what I did is I wrote these as, redraw them as two separate triangles. You have a big triangle and a little triangle, correct? So, the big triangle looks like that. That's triangle TWB, or BTW, by the way. Okay? That's the big triangle. The little triangle is this little one right here, and that's triangle ETC. So it's two separate triangles just drawn into one figure. And so if it makes it easier, draw the two separate triangles, then fill in the information that they gave us. Well, when I'm looking at the big triangle, from T to B is 20. So this is 20. T to B is 20. BW is 12, right? This angle down here is 79. This is all given to us. That's 79 degrees. And this angle is 34 degrees. Okay? That's the information they gave us. Now, when we're looking at, let's put in our values that they gave us for the small figure. Okay? This angle right here, that's the same angle. That's 34 degrees. This segment down here is 3. They gave us that. And that's all the information we know for the little triangle. Right? Okay. Now, they want us to find the measure of TEC. TEC. They want us to find that measure. What is that? What is it? 79. It's 79. This angle here and this angle here, because those two lines are parallel, they're corresponding angles. So if one's 79, the other one's 79. Right? Okay. And then it wants us to find ET and BE. Okay, so ET, that's this piece right here. So that's this piece right here. So that's what we need to find. So let's set up our proportion so we can solve for X. And then you have to find BE. So y'all go ahead and try to do that. They wanted us to find the measure of TEC. Well, TEC is congruent to TBW. If you follow that same pattern, you'll see TBW is 79. So those two have to be the same. Y'all see what I did? So if you figure out those same parts, TEC, that's this T, then E, then C, that's TBW. And you could just go find that, and it's going to be the same. Okay? ET corresponds with BT. Anyway, so use the similarity statement if you can't visualize what you need to visualize. Okay, did y'all get it? Okay, so ET, that's what we're trying to find this piece. So that's this here. So that's X. So we'll say that corresponds with BT. So 20 over X equals 12 over 3. And again, you may have it flipped. You may have X over 20 equals 3 over 12. Same thing. Okay? Or you may have reduced the 12 over 3 first and then cross multiply. That's fine also. And so when we multiply, 20 times 3 is 60 equals 12x. Divide both sides by 12, and you get x equals 5. Okay, so x is ET, so ET equals 5. Now, did y'all find BE? What is it? 15. How'd you do that? Good. 20 minus 5. Because if this piece is 5 and the whole thing is 20, then the rest of the way has to be 15. Okay, there was no proportion to set up for that. Okay, so BE equals 15. Okay, any questions? A question? Okay, here's another figure. And the double triangle and this figure right here, they're common figures. Okay? Common figures. You're going to see them again. All right? And so for this one, it's like they took a triangle. You had two triangles that were the same. They flipped it and put it like this. Okay? So they're like flipped one on top of the other like this. Now, they tell you that this line is parallel to this line. If that's true, what does it make line PR? What? A transversal. It makes it a transversal. If you see those parallel line markings, that's giving you information about those angles. If you see the parallel line markings, that's giving you information about those angles. So, if PR, if this is a transversal, what do we know about this angle and that angle? They're congruent because they're what? Alternate interior angles. So that means this angle is congruent to this angle. Likewise, angle N and angle T are also what? Congruent. So this angle is congruent to this angle because here's another transversal. They're also alternate interior angles, correct? So when you're trying to figure out corresponding parts on these two triangles, you have to pay attention to those angle markings because it matters. Okay? What do we know about this angle and this angle here? They're vertical angles, so they're equal, they're congruent. So this angle is congruent to that angle. Now, we haven't seen altitudes. I have the altitude in each one of those triangles, right? It drops from the vertex perpendicular to the base. The altitudes are also proportional. Okay? All the segments are proportional. So if they give you the altitudes, they're also proportional. Okay? So now see, you have to find QS. See if you can figure that out. They want us to find QS. So QS, they want us to find this piece here. So that's X. So when I look at what they gave us, hey, from here to here is 24, right? That's between angle 1 and angle 2. So between angle 1 and angle 2 is this, which is 16. So we can say 24 over 16 equals 6 over X. Or you could have said 12 over 8 equals 6 over X. Or you could have said 6 over 4. Or you could have said 3 over 2. Okay? Because that scale factor, you can reduce it first. All right? But in case you didn't, so now we have 24x equals, what's 16 times 6? 96. If you divide both sides by 24, we get x equals 4. Okay? So this is 4. Right? Now, a good question, it's not asking us this here, but a good question would be, how will we find this? Pythagorean theorem. You could use Pythagorean theorem to find this, right? We use Pythagorean theorem to find this because that's a right triangle. Now, same thing here, but is this going to equal this? Yes. That's an isosceles triangle. How do you know just by looking at the markings that it's an isosceles triangle? Because the base, it's perpendicular to the base and it splits it in two. So that makes QM a perpendicular bisector. Remember, perpendicular bisectors make that triangle into an isosceles triangle. correct? So this side, now it's not asking this, but that side will be congruent to that side based on that. Also, this side will be congruent to that side because that's also a perpendicular bisector. We know that because they told us that each of these two segments are equal. They're congruent, okay? Just wanted to throw that out there, okay? Any questions? So QS equals 4, all right? Now, try this one. Try that one. Same idea. Same idea. You have to figure out what to set up to what.